Bona fide D legend at this point, I think. He's involved in everything, and now he's going to give us a talk about D features, complexity versus benefits. So take it away.
Thank you. For those of you who know me, I'm Razvan, and initially the title of the talk was kind of different. It was kind of more pretentious, but then I just realized that it can be made much, much simpler. And the short version is D features, a rant. But before we go into that, a few things about me. So I've been contributing since 2016. I've been a pull request and issue manager since 2021. In early 2023, I finished my PhD. I'm also an associate teaching assistant at University Polytechnica in Bucharest, and I try to kind of preach D to students. And as of this year, I'm also a software developer at Chinopi, which is a software company that tries to tackle disinformation. Okay, so now let's get to the interesting part. So every line of code you adds complexity, right? And that is also true for the compiler, but that's okay. The complexity is justified if there is some benefit, right? Some return on investment. But since I've been a part of this community, I've seen that a lot of features where, at least from my opinion, it seems that the return, what you get from that feature is much smaller than the investment that goes into it. There are some features and people get like very, very opinionated about them and they want them to go in certain directions. But at the end of the day, it just feels like the complexity that they add in the compiler, it's just doesn't worth it. And for the rest of the talk, I'm just going to give you some examples. Some of them are like big features and popular features. Some of them are like quite niche, but I just want to show that like the main point is that every line of code we add to the compiler adds some complexity and it has to be justified. There has to be like some big benefit out there, and we have to have some people that actually benefit from it. And not just implement stuff and then go on and say, well, if you don't like it, just don't use it. I'm quite curious, how many people have heard about the line directive? Okay, quite a few. Did you know that we also have it in D? Okay, so it was implied that in D. Okay, yeah, there are a lot of people that don't know about it. So essentially, you can just like use the hashtag line 100, and what's going to happen is that basically at line 6, the compiler is going to treat it as if it's line 100. And you might ask yourself, like, why do we need this? Like, what use case could possibly arise? And so the thing is that essentially, like C's preprocessor, like when you include it, you include a file. If you have an error in that file, essentially you want the compiler to output an error at the line and the file name where in the file that you included and not in the file that the file was included. Does that make any sense? Okay, so, but like in D, we don't have includes that way. So why do we even have this?
It's used extensively in diet templates for Vibe. So you have a diet template, it's kind of a different language, and it transcodes that into D, and it puts the line directive. So when you get an error, it goes right back to where your source is.
Yeah, sure. I mean, I guess you could find some use cases, and also it's used. I mean, the only uses that I've seen is in DMD's test suite. You put hashtag line 1000 in this case. I mean, that's essentially all of the file. I don't understand why you would do this in this case. I know that, of course, so how things work for those of you who are not familiar with the code base, like you have the test output and you have like a script that extracts the test output, and then it runs your code and it makes sure that the output is essentially the same with what you have, right? But I mean, if you didn't have line 1000, then you would get, I know what you're going to say, but yeah.
Well, you said you didn't know why. You said you didn't know why, so.
Yeah, were you going to say that if you have like large files, you can just, and you add some code, you don't want to modify it?
Yeah, it reduces the diff when you add more error messages, which go in the top, and push everything down so it changes all the line numbers, and you got to fiddly fart around with it.
Yeah, okay.
So when you see the diff, all the error message lines have changed, except the only thing that changed was their line numbers. So this is an attempt to reduce the diffs.
When you look in GitHub, at least, it's just going to show you only the code that you added, right? So, and we do have a script that automatically fixes these errors for you, right? So if Yeah, and you can just run it, right? So I really don't understand why a line is used, and I actually hate it because when I review code, I have to do math in my head to find the actual where the error message should be, and sometimes it's really not that obvious. So it really kind of makes my life harder. So if this didn't existed for me, like it would be great, and we would. I mean, it's really not a big deal. It's not complicated to implement the compiler, right? But still, I feel that the return on investment for this is we're having a feature that really isn't that important. So, and it's actually used quite a lot. So it's used like 339 times in the test suite. Yeah, I noticed that you are the only one that uses it, Walter. So moving on, another feature that I don't really like is en-masse attributes. So essentially you have the possibility of putting at the top of your file, or actually everywhere you want in your file, private, nothrow, or any other attributes, and those are going to apply to all of the declarations where it makes sense to apply them, right? So the function is going to be private and nothrow, the class is going to be private, and the struct is also going to be private. This is very, very annoying. Imagine that you are at line 2000 and there's like, I don't know, a safe annotation or a nothrow annotation at line 5. You essentially have no idea of that, right? You're probably going to discover it, but this has bit me in the past. So at some point I was fixing a bug where some private symbol was, you could access a private symbol if it was selectively imported. Right. So, and I fixed that. So you weren't able to do that. And there was this project where I was getting an error and it looked like a public symbol could not be accessed anymore because of my patch. And I wasted some time until I realized, well, like that symbol was defined somewhere at line 1000. And I realized that there was a private somewhere at line, I don't know, 700 or something like that. I understand that it's easier, like you can just annotate with trusted an entire file and then your code is going to compile and it's going to be safe. But I just don't, that's just not good practice, right? And it makes it much easier to have all of these attributes or access specifiers at the declaration site for the person that it reviews it. And yes, it makes it a bit harder for you because you have to annotate it. But there was a famous quote last year from Attila. He said, "You may not like to wipe your ass, but you just got to do it." And I feel that this kind of applies in this situation. You see, complexity has a way to kind of breed complexity because now, because of this, people are arguing that, we should also add impure to the language. We should also add GC because what if you have like this en-masse attribute and you have like one declaration and, that uses a GC? It's like super hard to copy paste that declaration somewhere outside of the en-masse thing. You just need, another attribute for it. From what I've seen, like you have these features which have questionable value, and then people just start building things on top of them, even though like the alternative is much simpler. Like I'm just curious, for who here not having this in the language would be a deal breaker? Like you wouldn't use D anymore. This is like a super small thing, but we have it adds complexity, and like the value is kind of questionable.
I think En-masse attributes are very helpful, for example, when I'm writing safe code and I want to ensure that my entire code base is as compliant with safe where it can be. And in case I forget the attribute, it's actually going to bite me in the ass a lot later. And this actually helps me catch it very much earlier. And so I do think it's helpful. Essentially, it actually ensures that my code that is supposed to be memory safe stays memory safe. But in my case, I always stick it to the very top of the file. So I will agree with you when it happens in the middle somewhere, all right?
Yeah, I mean, you can argue either way, but it really depends on how you approach things. Like, for example, maybe it's a very unpopular opinion in this room, but when it comes to safety, we're not in that really good shape, right? So my point is, like, if you really need memory safety and it's critical for your application, like, you might as well use Rust, right? So. Yeah, so I mean, I get it. Like, people argue for all sorts of things. I know that what I'm saying is controversial, but yeah, I'm just trying to provoke people to kind of see beyond.
A brief question on that topic. So in C++, for example, it's like a stylistic convention to have like in a class, like a private section and a public section. Do you have the same feeling about that usage?
Yes. Yeah. Just put private everywhere.
Okay. Well, more like Java style.
Sorry, I didn't.
More like Java then.
Yeah. Yeah. I mean, I really don't see that much of a benefit in it.
I just want to say that the main use case for TIS is putting things at the top of the module. So we could just accept it on the module declaration, call it a day.
Yeah, I mean, that could work, but you will see that later in this talk, I'm also against attributes in general. Okay, now let's talk a bit about public and private overloads. So there's this long-standing bug. I think this bug might be older than some people in this room. And it's kind of embarrassing, at least from my perspective. So essentially, if you have like a file over.d and you have two overloads there, one is private and one is public, if you just import the module, you're going to be able to call the private function. This bug has been like forever in D.
Yeah, that's a bug that can be fixed, but it's not. I'm not sure that means that there's a design error. It's more of a bug.
Well, it depends. Like, just let me go on a bit. So, I wanted to fix it, right? When the compiler sees like the invocation of fun, it searches for the symbol. If it's not in the module scope, it starts looking at imports. At imports, it sees that fun is defined in module over, and then it says, okay, I found a match. Actually, I found the symbol. Then if the symbol is an overload set, it just tries to match the function. I mean, if the most visible overload is private, then it says like, no, you cannot access it. But if the most visible overload is public, is accessible, then it goes on to the next step where it tries to do a function called resolution, right? And it sees that the private one should be called here. Now, how to fix this? What was missing is to check the access specifier after you've done all of this, and that fixes the issue, right? You just say, well, you cannot call it because it's private. But if you fix it that way, then you're also going to break public aliases to private functions. This code works today, right? So if you do a public alias to the overload set of gun, it doesn't need to be an overload set, right? It could also be like private void gun, and you do a public alias t, and then you just call t, and this should work. Now, when I tried to fix it with the previous fix, it broke this code. So this code didn't work anymore. Why? Because the compiler substitutes aliases eagerly. When it found t and saw that t is an alias, it immediately replaced it with gun. Gun is a private symbol now. So if you do the check for the access specifier, you're going to end up with an error. I would argue, like at that time, I was like, why do you want to, like a symbol that is private, why do you want to make it public for an alias? Sure, there are going to be people in this room and they're going to say, yeah, well, it's this use case and yeah, it works, but it just doesn't seem like a correct thing to do. But either way, this was the case. Still, we need to fix this bug, right? So an alternative to this would be to simply do not allow mixing public with private overloads, right? Or overloads that have different access specifiers. That is going to fix the initial bug, because if the most visible overload is private, then obviously you're going to say, well, you can just access it from over 2 because it's private. And it also lets this code, this code is not going to work, but you're going to get an error that you cannot mix the private version of gun in the same overload set to the public version of gun, right? And you just put out in deprecation and you suggest to people that they, rename the function differently. That might be a bit complicated for constructor overload sets or special functions, but yeah, you can just rename them like that.
I don't think I understand the problem here. This should fail to compile as far as I'm concerned.
This example?
Yes.
What should be the error?
The error should be you can't call gun because it's private.
But you have a public alias to it.
Sure, but you can't call that particular instance of the overload set because it's private. The alias is public, but what the alias isn't.
That's what I argued also. So, but there are people in the back that want to contradict you.
Well, the problem with them is they're wrong.
Who was first? I think you were first. Right?
The error should actually be argument mismatch error, because we moved away from accessibility to visibility a while ago now. So when it does the resolution, it shouldn't even consider the private one. It should see a subset of the overload set that is only visible to it.
Yeah, but if it's not an overload set, like if it's just a private void gun and you make it public, should that work?
Okay, so the alias thing is another thing that there's literally thousands of lines in MD to work around that issue. So if you ever want to fix it, I'd be very happy.
If you remove the public overload, then it should be it is an error, right? Because you try to compile with the
No, it's not. Under the current rules, it's not.
If you remove the public
Yeah,
overload and it's just a public alias to a private function.
Yeah, it works. Yeah, it compiles.
Really? Yes. Okay. Things have changed then, I guess.
I think it has been so for some time. And the same problem applies. Like, for example, if you have a templated function which receives an alias, template parameter, and you pass like a function which is private, then with the check that I implemented, you would get an error, but right now you don't. And I remember you, Matthias, arguing that this code should work, like if you have just a private overload. Like you are the one that closed my PR. So I'm really glad that you changed your opinion on that. Yes.
I mean, I have to side to some extent with Razvan here. I'm not sure what is the use case for a mixed visibility overload set. On the other hand, of course, you can merge overload sets from different modules. And then there's a question, what does it mean for the visibility to be compatible?
Yeah. So anyway, when things, in my opinion, start to seem that they're very complicated, like just do the most restrictive thing, see how people react, and then maybe see how you can extend it in a way that makes sense and doesn't add too much complexity to the code base. Because, yeah, I tried disallowing this mixed qualifier thing in the overload set, and like all hell broke loose. Like there were tons of projects on BuildKite that were failing. Yeah, and I remember your comment, Matthias, where you said something like, looking at BuildKite should give you a pretty good idea why this is a bad idea. But still, I think it's the sensible thing to do. And we can figure out like the thing with the alias and merging overload sets. Either way, moving on to the next topic, like mixins. So if I got some pushback at when I talked about the line directive, I'm really wondering what's going to happen with mixins. So my main problem with mixins is that they tend to get complicated. Like whenever I think of mixins, I think like, well, I don't know, you just go on the street and you just leave guns, like automated guns. And yeah, some people will just use the guns to defend themselves, but there's probably going to be a lot of people that they just, they take the guns and they start shooting people. This is actually the implementation of bit fields in the standard library. So I don't know if you used bit fields from the standard library. So it's basically a templated function that returns a string, and you're supposed to mix in the string that the bit fields function returns. It's a very clever way to kind of allow bit fields at the library level, but like, look at this code. Like, if you want to maintain it, if you have to maintain this code, yeah.
I've had similar problems with the mixin using strings, and I've tried to use like the mixin template, which has better syntax checking wherever I can. Although I found some places where I can't. Like, for example, if I need to declare a variable that is related to, or to make a function that's related to a variable. Like, let's suppose I have some annotation that when processed will make a cached version of a lookup function, and I need a way of declaring a function based on the name of the variable. Like using mixin template, I'm not aware of a way to do that.
Yeah, so the thing is with mixin templates, you do have some visibility issues. I don't know exactly what the state is right now, but sometimes it happens that you mix in some functions or some variables and the compiler just kind of fails to see them when you try to access them. So I don't really have an answer to your question. Yeah, my only point is that if you go crazy on mixins, like code ends up like this. But on the same time, I understand that they're very powerful. And they're actually used a lot in Phobos. And if you're using mixins for like small portions of code, it makes sense. But if you're going to try to, generate a lot of things, then things are going to be a bit wild. And there's a lot of issues with mixins. So I counted like 234 Bugzilla issues. Yeah, there are some questions.
it's a cost benefit thing, right? What I will observe about Mixin is that Mixins can actually be the most readable solution in certain settings. For example, if you're in a leaf function, generating something code, and it's like the last level of elaboration or extension, right? Then it can be incredibly readable. But of course, the problem is that you're on your own with respect to basically the type system says, "So long, sucker." I mean, so you have to take over at that point, right? But this is a characteristic of anything that is sufficiently general as an escape hatch. Whenever you have an escape hatch kind of functionality like this, it's certainly tempting to abuse the hell out of it. And so, yeah, I kind of feel your pain a little bit, but I wouldn't want to see it go away.
Yeah, sure. So I'm not advocating apart from attributes, which is the next thing, I'm not advocating that we just delete these features. I'm just trying to point out that all of these features, they add complexity. And in some situations, it's really hard to deal with all that stuff. And an alternative, up until now, our approach to this was we're flexible. You can do whatever you want in D, right? We're supporting everything. This has led us to this point where we have a lot of issues and a lot of our language features don't actually compose very well. So I'm just asking maybe it would be better to just start off, with a subset of what you want to implement and then see how things go.
This is one of the use cases that we targeted for interpolation, and we should try and figure out a way where we can use interpolation directly instead of having to pass it to text so that it runs a bunch of CTFE. That would make that file a lot more readable because you could use token strings and make it just syntax highlight everything.
Yeah, indeed. But there's also there are these issues with forward declarations, right? So you see this example here. And currently it's not, there is a solution, but it's not quite obvious. So what happens here is that this is going to be an error. So B is going to be an undefined identifier because when the compiler searches for B at module scope, it just sees the mixin. And yeah, a solution to this would be just do a different pass where you're just expanding mixins and static if and static conditions and so on. But that adds more complexity.
I've been long aware of this problem, and that's what string interpolation was supposed to mitigate. I've also written my own little function that runs in compile time that produces a string as output and makes it easier to read. So, there are solutions available for this. I looked at the C++ one. That's even worse. So I don't think we're in terrible shape here.
Don't ask for questions. Just enjoy your talk.
That was definitely worth waiting for. Thank you, Robert. Please continue.
Okay, so moving on. This is the star of the show. Alias this. So I don't think there's a feature that, since I've been contributing, gave me more headaches than alias this. So let's begin. I don't know if everyone is familiar with alias this, but how it is branded is manual subtyping. So essentially, if you have this object, let's say it's an object in a library, which has some functionality, in this case, it just has a field, and you want to kind of wrap that struct, but also add some other functionality, right? You basically want to extend it somehow. Alias this gives you this possibility, right? So you can just declare my wrapper, and then you can use it as if it was a library struct. If you would have added other fields and other methods, you can also use those, right? This is probably immensely useful in some situations, but because alias this wasn't, I don't really know the history of alias this, but it seems to me that it wasn't properly designed because you don't really know how it interacts with other features, right? So for one thing, let me give you an example with classes. Alias this works with classes, but on the same time, we don't have multiple inheritance, right? So multiple inheritance is not defined in D. But now if you use alias this, then you suddenly have undefined multiple inheritance, right? Why I say undefined? Because you don't actually know how all of this is going to work, right? So in this example, you have a class which has a function, and then B, which is a completely different function from A, which also has it. And then you have C inheriting from B, but you also have a field A, and you manually subtype it. Now, when you call C.fun, which fun should be called? This is not defined in the D documentation, right? So it could be argued both ways. So yeah, sure, this could be defined, right? We can talk about this. But if we don't want, multiple inheritance in D, why do allow it with alias this? Yeah.
I mean, we do have multiple inheritance in D. It's called multiple imports, and we actually solved this problem there. And I think we should use the same solution. And the reason why we don't is not breaking code. So we should do this in addition, I think.
Again, I think, yeah, every problem has a solution, right? But you're still adding complexity to it. And I'm not convinced that, I know that Walter is against multiple inheritance, and I'm kind of with him on this. So
you're not adding complexity by using an existing rule somewhere else.
Maybe not from a design perspective, but like from a code-based perspective, you will need to add some code, right?
You will need to delete a lot of code in this case and reuse the existing one.
Yeah, still, this is like one aspect. Oh.
To my knowledge, because I've done this once, actually using alias this inside a class issues a depreciation warning.
It used to. I made a pull request, but it was reverted.
Okay, then never mind.
What alias this does is very important. The problem is we screwed up with it. The first thing is the syntax. I could never remember if it's alias this A, alias A this, A equals this, alias this equals A. I could never remember it. The syntax is absolutely terrible. The second thing is, since it is basically inheritance, I don't think it has any place in the class hierarchy, and it shouldn't be there. But it has a place in struct. And I would change the syntax of it so instead of alias A this, you would have struct C colon A. and then it's
yeah, so it's basically inheritance for structs.
Inheritance for structs, and then suddenly everybody knows how it's supposed to work because it's something familiar rather than something peculiar.
Yeah, that works.
I just want to say for the record, first of all, if you have struct inheritance, there are some rare useful cases that absolutely should not change this or stop this going forward. But occasionally it is useful to be able to either access the fields or the entire structure of a member. Also, I just looked it up, and very, very technically, this is actually defined behavior. It's going to access the function from the parent because alias this is only invoked if the lookup is otherwise undefined. But you are completely right about this being terrible.
Yeah, but I mean, I don't want to make this about let's fix alias this for classes. Like, yeah, that's a problem, and it might be fixed. But then there are other problems. Like there's this very old bug with overload resolution. If you have a struct and you have like an int and an alias this to it, and then you have like two overloads, one that gets an int and the other that gets a const s. And then you call foo of s. Which overload should be called? Yeah, the first. Why the first? Maybe the second. Why not the second? Because it's a const conversion. It could be argued both ways, right? But if you look at the compiler, like the compiler has a very simple matching strategy. For example, if you would call foo with a const s, then it would be like an exact match. And that would be preferred over all of the... If you have two exact matches, then you're going to do an error. In this case, what the compiler does, it tries to convert s for the second overload. It sees that it is a match constant. So match constant is like you have the same type, but it needs to be promoted to a const qualifier. The convert one is where you actually do a conversion, right, from one type to the other. What happens here is that the alias this is an exact match, whereas s, the actual instance, is a constant match. It's going to call the first overload with the alias this, which, at least in my opinion, it's surprising, but I know that you can argue both ways, but I would expect that indeed, like, if you follow the compiler, like a constant conversion is superior to a convert. So the problem here is that when you are matching functions with alias this, the compiler doesn't consider it like a convert match, which it should be. I tried implementing that. A lot of code started failing, like breaking changes.
You had an earlier comment about the general thrust is about complexity and relative value. And just noting a couple of things. One is that there are two different types of complexity. One here is, like it's a bear to do in the compiler, right? It's a mess. It's hard to do. Bugzilla has this, 2-decade-long list of screw ups, right, or something, and that's one complexity. And the other is the complexity as presented to the user of the language, right? Is it immediately assimilable? Could you immediately quote the rules, that kind of thing, which you're revealing. So my observation here is that this is, in fact, the hard work, I believe, of language design. This is the hard work, which is power. You want power, you want readability, right, and you want simplicity. And it's just readability and simplicity kind of related. And I guess composability, as you've mentioned earlier, but it's the hard work. And I'm really hopeful that the additions thing helps us go forward. But I've heard additions cited so often that I'm just thinking this is some Kool-Aid. I don't know that this is going to work. I hope it does work.
I'm going to touch on additions in a bit.
I really hope it does work. But this is the hard work. And I'm especially happy to hear things like Timon suggestion, this doesn't change anything. You can remove stuff. Those kinds of things are to really be praised. And I'm happy that you're turning it over, that you're, in fact, you've actually energized a few people here, I think. This is good.
So if we were using classes here, so class S with a parent class of A, and the first overload was A, and the second was const S, which one would be preferred?
Yeah, it would be the second one, because in that case, it is a match convert.
Yeah, so it should behave the same.
Yeah, but I remember when I started working on this, people would say if you want to fix it, think of if you had classes, what would happen? Well, I feel that ship has sailed a long time ago. Alias this has deviated so much from that. And it's like a lot of happenstance semantics in many situations. And to go back to your point on complexity, the thing is that it's hard to tell whether the problem with alias this is that it wasn't properly designed from the beginning, or the fact that people just came and said, in this situation, this should happen. And they went on and implemented it like a special case or something. And then special cases started piling up, that it's really hard to tell what happens in certain situations, right? Yeah. So when I tried to fix this, there was no way, putting it a match convert. I don't actually remember, but it broke a lot of projects. And there was an alternative implementation where you add a new matching level, which is match alias this or something like that, which is under match constant, or between no match and match convert. I don't actually remember. But Walter was adamantly against it because, and I actually will thank you for that, because the match thing is very simple. Anyone can understand it. You don't have to be a compiler developer, right? And this sort of simplicity is what actually has drawn me to D. And this sort of simplicity, I feel that it's not valued anymore in this community. You have all sorts of features and people are saying it's immensely helpful. Yeah, but it's super, super hard to implement. And this sort of complexity breeds new complexity. And you will be at a point where you will not be able to implement anything in the compiler because you have tons of special cases.
We can't fix alias this because every attempt at fixing it breaks legions of code. However, we can replace it. And I suggest replacing it with struct single inheritance, and then discourage people from using alias this and use the new one. And we all know how struct inheritance should work, so that shouldn't be an issue. But I'm also glad that you appreciated my adamancy about the... because I can tell you from experience, nobody knows how overloading works in C++. Even people who write C++ compilers, and I implemented the damn thing, and I can't tell you how it works. Because it's pages and pages in the specs of if this, then that, if this, sort of like that. And it's just impossible. And how people deal with overloading in C++ is they try random things till it works. That's why I was so adamant about sticking with that scheme on matching.
Okay, so now moving on, the final part with attributes. Let's just take them in order, like pure. You have functions that can be strongly pure and weakly pure, and the whole idea behind them, I think, was that maybe the compiler can do some optimizations with these, but it turns out that the compiler doesn't do any optimizations on pure. And also, it was one of the reasons why the metadata immutable dip was killed, because like what happens with strong purity, right? If you have like, I don't know, immutable struct at the top level, and then that immutable struct is accessed by a strongly pure function, that's completely fine because technically you cannot modify it. But now if that struct has a mutable field in it, then you're breaking purity, right?
I can tell you what pure is good for. It's so you can write multi-threaded code and not have to worry about side effects.
But
that's
don't
what
we
it's good
have
for.
like shared for that?
No, pure is different because when you're doing multi-threaded code, you generally don't want to touch any kind of global state, including shared.
Yeah, since pure is completely stateless, that way you can do completely reliable parallel processing and multi-threaded code. That's its purpose.
I mean, this feels like this is something like a linter should do. Why do we have to have it in the compiler? Like,
No. I'm sorry.
That's what it's for. And that's why, people complain that pure is too strict. Well, it has to be strict for multi-threading. Yeah, it's a bondage and discipline thing. It has to be that way because then you can fire off a whole bunch of pure functions. They run in parallel and you don't have to worry about any synchronization with it.
Yeah, are there people here who are doing multi-threaded application and using pure?
Yeah.
And it really does help you.
Oh, sorry.
It's honestly a critical component, especially if you're going for task-based threading. We do not want anything touching the global state at all. And ensuring that at the compilation level stops people from writing bad code effectively.
I do some multi-threading code where pure doesn't actually work for me. It just as a usage pattern, what happens is that you're actually spinning out different sections of arrays. For example, like you get this portion, you get that portion, you get the other portion. So depending on how you define the isolation, you still have issues that the programmer has to maintain themselves.
Yeah, my point here is that pure is for the rest of us who are not using it, is like a really big pain, and it adds complexity to the compiler. Like, we're gonna talk about also like what pure did with the templatizing of runtime. So that's why I feel it's something that should be outside of the language.
Yeah, I just want to mention one thing about pure. There is certainly optimizations that you can do with pure, like strong purity. The compiler doesn't do it like. I think DMD doesn't do it, but LDC actually infers purity. If it has all the context, you can optimize it.
There was an optimization that was done, but it turned out that it was buggish and it was just removed. So, yeah.
I wrote some stuff that depends on pure. So for SIL, the language in Symmetry, I wrote something that if you give inputs and output, it will find what function will map those inputs to that output. So for you know what you want to do, but you don't know what the function's called. But it only works with pure functions because you don't want hard drive.
Yeah, again.
So there's that. And secondly, there's a question of creating immutable values from pure functions. So that's really, really multi-threading as well. And the Pony language has a transition thing that they have to use to be able to construct it, because it's basically, modifying something and then returning it and then basically transitioning that to immutable. And we don't need that because of pure functions.
To me, it feels like pure. Of course, I mean, any feature is going to be used at some point by someone. It's going to be found useful. But if pure is important for multi-threaded application, then I don't know. Maybe it should be spelled differently. But the thing is that pure is also impeding like developing some stuff. And now people are talking like, do we want to have like the standard library to be pure or not? It comes in a lot of design decisions where I feel that it's something which honestly it goes down to taste.
Modifying global state is usually not a good idea anyway. So for me, pure should be the default even.
You've just touched on this, Razvan, that since pure is mostly used for multi-threaded work, then why not change it or just add a thread safe attribute and then discourage people from using pure? So then you get the functionality and perhaps some other checks for thread safety and not have to deal with pure so much.
Not a big pure user, but the fact it creeps up in identifier like pure malloc or versus just malloc is not a good sign. And I think it does segment the code base around there.
Okay, so we have some experience with pure and other attribute in general being a problem. The policy that we ended up with is that you generally don't want to use them, like even if the function is pure, unless you actually need it. So in case you are building something multi-threaded or whatever, and the pure constraint is important to you, then make a pure function. But please, like, just don't feel like annotating half of your function in your code base as pure just because they are pure. In my experience, at least, this is where you run into problem. It's like when you start, dutifully and diligently annotating everything, it makes the code very inflexible. Every time you refactor something, you need to change the attribute in half the code base. This is really bad. But in itself, like if you want to use pure because you want to do parallel processing, we do that, and it's a very good idea, and it provides good value. Just like don't feel the need to put it everywhere.
Yeah, to move on, like what I want to share is that the pain when we tried to template runtime hooks. So what happened like before when the function, so these functions in the runtime, some of them were using some global state, but because the compiler was lowering to them and then the code was linked, the compiler just said like, they're pure, it's fine. Yeah.
Regarding the mutable dip, I mean, my original draft actually came with the proposal to define more formally what pure even means in terms of what rewrites are allowed. And I don't think pure killed the mutable dip. It's more.
I said it was one of the factors that was also with shared and immutable. So,
I mean, it's more that the mutable dip was trying to solve a problem that I thought. I don't know if we need to solve this, but if we solve this, we shouldn't break the other attributes. So we need to give them a meaning that is not based on like physical memory locations. And I still think that could be done. Maybe unmutable is not the best way to go about it, but we should still define what the attributes mean, I think, in a semantic manner.
Yeah. And like going back to what I was saying, like when you started templating all of those methods, you would get like a lot of errors, like this thing is not pure, this instantiation is not pure. So we had to like work around it. So I have heard what you said. I feel you. There are use cases where pure is useful. But from my experience, I mean, I don't use it, and it's mainly a pain whenever I hit pure. Is like when I do some compiler work, and it's always like super annoying. So yeah, I guess this does not apply anymore. But now next, nothrow. So nothrow is for functions that are not supposed to throw, but it works if the exceptions are caught. So the performance argument doesn't stand here. But I understand that if you have like some client code and you don't want, you want to make sure that there aren't any exceptions that actually are thrown. You don't want that to happen. But still, again, this feels like something that the linter should do, right? So yeah.
The purpose of nothrow is a performance optimization, because when you have RAII, if there's a potential for throwing, that means you have to build an exception handler around the destructor. And if it's nothrow, it doesn't have to do that. So it's a significant performance enhancement, and that's what it's for.
Okay, so the way this works is that the regular user who doesn't know that should just put the nothrow around.
If he's not throwing in exceptions, he can just put nothrow on it, and then his RAII code will run faster.
Yeah, in this case, I think it makes a lot of sense, like nothrow to just be implied by the compiler, to just be inferred.
Well, inferring has its limits, okay, because any functions that function calls may throw, and the compiler needs some assurance that those aren't throwing, so it can eliminate the need to have unwinding code in there. And you can see this by building some code and making it no-throw, not no-throw, and looking at the generated code.
NoGC at safe, I feel that, they do have a usefulness, but as I said, if you're really interested in safety, you can just go to Rust. I've been doing it, I've been advertising it to students, memory safety, D, and so on. But as time passes, I just don't feel comfortable anymore, saying this. If safety is critical for you, I don't think that with the bugs that we have and with DIP 1000 and with everything, I'm not comfortable recommending people use D for safety. And yeah, NoGC is kind of okay, so. My main takeaway from this is that this is probably something that the compiler should not do. This is actually the job of a linter. The thing here is that we have all of these qualifiers, and yeah, people have all of these arguments that, it's immensely useful for me in this case and in this case and so on. But yeah, if someone comes and says, I want some code where I don't have any assignments, are we going to create an attribute for that? I know it doesn't make sense. It's just for the sake of the argument. Maybe an alternative approach is that you have this tool and it's really easy to customize it and to just using DMD as a library, and then you just do a pass on the code and you get all of these warnings. It's really not something that the compiler should do. Yeah, as we've seen, these attributes, they add some complexity that lead to other forms of complexity, not to mention that right now we're talking about inferring attributes for all of the functions, but we have this problem that was also mentioned where if you have two functions that call themselves recursively, that's a hard problem to solve, and it's been lingering around. And now that we have them, we're having all of these discussions, we need to support them in Phobos v3. Should we make a version that throws and a version that doesn't throw, a version that is safe, a version that is trusted, and so on and so forth, and just it just feels like we're kind of missing the bigger picture here with attributes. Now, editions. If I would have to sum up what I feel about editions is please don't. The thought that we would have to support every mistake that we've done, I don't know. I have nightmares with this. I'm terrified of how what this is going to turn the compiler into. I know it sounds good, yeah, we're going to have everything forever, but there are certain situations where it's really not obvious how you are going to you will be able to support multiple editions for the same feature, and that means that all of that terrible stuff that I showed you with alias, this is going to be there forever, right? And on top of that, we're going to implement subtyping for structs. To me, that seems like it's not a maintainable thing. And I want to interject a bit here and say that deprecations are actually a good mechanism. I really don't understand why we are so keen on editions and we hate deprecations so much. And I think that the interpretation is that there was this thing with DIP 1000, the mistake we made that actually made the deprecations be a villain is that there was a point where we were thinking, yeah, we want DIP 1000 to be the default. So maybe we're going to start issuing deprecations for code that is not using DIP 1000, but doesn't abide by the DIP 1000 rules. And that was the point where people started having tons of deprecations and going crazy, I'm so tired with all of these deprecations. But before that, yeah, we were still deprecating things, but that was the sensible thing to do. In most of the times, we were deprecating things that were broken. And I think that that's quite okay. And I actually urge you to reconsider this, because the editions thing, I honestly hope that it's never going to be ready, because it's going to be a disaster to the code base. So I'm sorry if I'm blowing the air out of people's balloons here, but I think we also need to consider the complexity of the code base. So for conclusions, complexity breeds complexity, and we really need to make sure that what is added actually brings tangible benefits. And I know that that's hard to kind of measure, right? So we don't know, but oftentimes when I read the forums, I just feel that a lot of debate is going on topics that are actually not so important. I've seen your posts, Manu, and I mostly agree with what you're proposing there. And I think that people that actually have, commercial experience in this should have louder voices over there. And still, we need to be able to reduce the compiler's complexity. And if we ever have editions, I think that the complexity is going to blow up exponentially. That's everything.
Okay, more questions now. So how would having attribute inference on non-templated functions ease the situation? Reflection number 2 is I recently watched a talk at C++Con where they discussed what really safety means, and it turns out that just using Rust is in some situations like building a graph structure not self-evident that it's going to be easier for the developer to build it in a robust way, because they need to simulate pointers using indexes. And what you do then is you to basically convert the memory null checkings to bounce checks. And if you fail that, you can get also get like indexes that are out of date, meaning basically simulating memory errors in a logical way.
Yeah, there's actually, I think I posted, there is this GitHub profile where you have like a collection of memory corruption programs which are done in safe Rust. So it's like, here are your memory vulnerabilities in Rust. Yeah, but to comment on the first question, I'm not saying that attribute inference is going to fix all of these problems. So in my ideal world, like all of this attributed stuff is going to be done by a linter. It's not going to be in a compiler. But with regards to the nothrow thing optimization, right? You could have the compiler infer nothrow, right? So it's being done for templated functions. So I don't see why it wouldn't be done for normal functions.
Yeah. So on nothrow, topically, I understand the optimization benefits, but for me, their benefits go beyond that. We use nothrow and nodegc together in our code base. And while it, obviously we're doing this time critical stuff, but nothrow also helps me reason as a developer about the code flow. I don't know how you do code coverage analysis in the face of exceptions. And nothrow provides a guarantee that I'm not just nothrow, but everybody I call is nothrow. And that is an incredibly useful attribute. So I would not like to see that discarded. Actually, yes. Actually, going back to one of the Phobos 3, there was discussion of a low level. I was very pleased to hear that it wasn't just going to be nodegc, but for the 2 levels sort of approach, but that the other library would allow us to actually just get an error. I would rather get an error and handle it in certain code paths because I can reason about it.
Yeah, well, my opinion here is that we are a language that has a garbage collector, and we are a language that has exceptions. So one stance, of course, it can be argued both ways, but to me, it feels a bit schizophrenic that we have all of these features, but then we offer all of other features which kind of make sure that you are not using them. Like, they should exist, but I think we should just pick one side, right? And just go like, most of the people, they're going to use the GC and exceptions. And like, if you want to do like some exotic things, sure, we can have like some libraries. We can have like some, extra checks and linters, whatever, but you are not like in what the language was designed to do. So
if you want to do that, then you're designing Go, not a systems language, right? And I love Go.
I know I've argued with you about stuff like this, but I'm actually very glad you're bringing this stuff up, because every once in a while we need to sit down and revisit our basic assumptions about the language and decide if they're actually working for us. So I know you've been heckled a little bit about this, but I really appreciate you bringing up these things in the talk here. It's, the responses from the audience and the interest it generates, I think, is very valuable for us. So thank you.
Well, and with that, your job is done. Have a break.